group of learners uses the reaction of excess hydrochloric acid and a zinc to investigate factors which influence the rate of reaction. So the rate of reaction is the independent, or is the dependent variable, sorry. The balanced equation is given. They use the same volume of HCl and 1,2 grams of zinc in each experiment. The reaction condition and the temperatures are readings before and after completion of the reaction in this experiment are summarized in the table below. So we have experiment 1, 2, 3, 4, 5. Then 0,5 concentration, 0,5 concentration, but up 0,8. So the concentration is 0,8 higher. Then we have the temperature before and after. So that is the temperature of the reaction mixture. So ENUC, as you can see. So we have the state of division. This state of division is also known as a surface area. So sinalezi granules. So granules lesser surface area, smaller surface area. Sine powder, greater surface area. Sine powder, greater surface area. Sine granules, smaller surface area. Granules, smaller surface area. So these effectors. Now let's go to equation. What is the reaction between hydrochloric acid and zinc exothermic or endothermic? The answer is exothermic because the temperature increases during the reaction. So a temperature yenyuka, which means there is more energy released than absorbed. So the temperature increases, which means the reaction is exothermic. Then it will give a reason for the difference in rate of reaction in experiment 1 and 2. Let's look at 1 and 2, the difference. 1 and 2, the concentration is the same. The temperature is not much important, but the state of division or the surface area is not the same. So experiment 2 has a greater surface area or a greater state of division. Therefore, the reaction rate for experiment 2 will be higher than the reaction rate for experiment 1. Okay, so sidlule kuleni question. Let's go to question number, this one, question number 3. Learner compare the results of experiment 1 and 3. Now the focus is on experiment 1 and 3. Sorry for that. Between 1 and 3. So if strong difference 1 about 3. This is experiment 1. This is experiment 3. So the concentration is not the same, right? This is the reason. Now let's come to the state of division. This one is powder. This one is granules, which means the state of division is not the same okanye surface area. So sinantoni, sine concentration engafaniyo, siphinde sibe ne state of division or surface area engafaniyo. Masive bathini, to draw a conclusion regarding the effect of concentration on the rate, give a reason why this is not a fair comparison. It is not a fair comparison because there are two independent variables. There are two independent variables. The temperature, not the temperature, the concentration of experiment 1 and 2 are not the same, and the state of division is not the same. So there are two independent variables, which is the concentration of HCl and the state of division of zinc. So that's not fair because the sijonge concentration space jonge is state of division. So the comparison is not fair. Now we're done with that. Okay, let's go to this question. It's in the question. How does the rate of reaction in experiment 5 compared to the rate of reaction in experiment 1. This is 1. This is 5. The concentration is the same. Good. Okay. The state of division is also the same. Okay. The concentration is the same. The state of division is the same. Look at the temperature. Look at the temperature there. Okay. So everything there is the same, which means there is an extra factor e-affectiweyo phaa. Umzekelo, maybe kwenye ye-experiments apho ku-addwe ntoni? I-catalyst. Because if you can look at ixesha, le ithathe ixesha elincinci kunale. Le ithathe ixesha elincinci ine-higher rate. The rate is very high here. That is why ithathe ixesha elincinci. This one has a lower rate. Masive question ebithini ke ngoku. Write down faster than. How does the rate of reaction in experiment 5 compared to that in experiment 1? Write down faster than, slower than, equal. So because of elaa xesha silibona phaa, the answer is faster than. The answer is that faster than. Then kuthiwa ke ngoku write down the factor. The factor engaba yenzekile phaa is the addition of a catalyst. The catalyst is added. Ngenxa yoba ezi zilapha zonke zirayithi ziyafana. So kushiyeke ntoni ke ngoku kwezi factors sinazo? I-catalyst. So kuaddwe ntoni ke ngoku? I-catalyst phaa. So kuthiwa ke ngoku by referring to the collision theory, how does this factor affect the reaction rate? Now that si-adde i-catalyst kuzokwenzeka ntoni? I-catalyst lowers the activation energy. Lowers the activation energy. So after the activation energy is lowered, there are more particles with kinetic energy that is greater or equal to activation energy. Now that there are more particles that will be able to move, ithetha ukuthi there are more effective collisions per unit time. More effective collisions per unit time. Xa u-adde i-catalyst, you are lowering the activation energy. Sitsho zibe nintsi particles with kinetic energy greater than activation energy. Therefore, the rate of reaction in experiment 5 is higher than the rate of reaction in experiment 1. So sigqibile, let's do this one. Calculate the rate at which the hydrochloric acid reacts in experiment 4. The rate must be in mole per second, which means we need the number of moles now. Now we are going to calculate the rate. The rate in this case, ngenxa ye-SI units, the rate will be the change in number of moles over change in time. If we use experiment 4, this is experiment 4, the time is 8 seconds. Delta T is equal to 8 seconds. Sicalculate i-rate, sijonge kwi-HCl, sijonge lapha ku-HCl. Okay. Now we have the mass of the zinc. We have the mass of the zinc. The mass of the zinc was given. Mass of the zinc initially. Mass of the zinc initially is 1,2. The initial mass of zinc is 1,2 grams. Masiqale sibale number of moles ke ngosibone uba sizothini. Then let's calculate the number of moles. The number of moles here will be equal to N is equal to M over capital letter M. Let's go to the periodic table. This is 1,5. The molar mass of the zinc is, where is the zinc? 65. Okay. So sithi ke ngoku 1,5 kwi-capacity. Let's go back to equation. Remember, siqale sibale i-number of moles, then siyophendula equation. Calculate the rate at which the hydrochloric acid reacts, which means we need the number of moles reacted to calculate the rate in this question. Reacts. So the number of moles reacts sisifumana kwi-mole ratio. There is 1 here, there is 2 here. 1 is to 2. The number of moles of the zinc, leno 1, was 0,023. Number of moles reacted zalapha asizazi, then we cross multiply. The number of moles reacted with HCl will be equal to the number of moles of HCl reacted, and the question said calculate the rate in moles reacted. So ithethe ukuthi sebenzisa eza number of moles sithi 0,046 divided by ixesha bingubani bingu-8, then we get the rate. Remember xa sibala i-rate, i-SI units sixhomeke kwi-question kuthiwe mole per second. So laa mole iyasixelela uba we need the number of moles, that is n. So ilula kanjalo sibe siyigqibile lena question, that is 15 marks. Now let's go to question number 3 of the rate.